Welcome to N is for Networking. I am Ethan Banks with Holly Metlitsky. I have been designing, building, and operating networks since the 1990s, and Holly's just getting into networking. She's got a couple of years and a bunch of certs under her belt, and together, the two of us navigate the complex stack of technologies that make up modern networks and help you figure out what's going on. Like, I gotta tell you, life was simpler in the 90s. It really was. Networking has really changed so much here in 2025. You can follow Holly and I on LinkedIn or join the Packet Pushers community Slack like many others have done. If you're looking for us on LinkedIn, you can just search for us by name, Holly Metlitsky or Ethan Banks. And then you can join that Slack group via packetpushers.net/community. That Slack group is free, by the way, and you're going to be joining a group of network, cloud, and security engineers from all over the world. There are over 4,000 people in the main channel now. And everybody is in there exchanging information, giving advice, sharing memes, and just being awesome people. There's just a bunch of really great people in that Slack group. In today's chat on N is for Networking, Holly and I are going to consider a listener question from Douglas. And Douglas has sent us a list of questions quite a while back, and we've been working through them here and there. And Douglas asks us this: how do you approach designing a network for high availability and redundancy? How do you approach designing a network for high availability and redundancy? All right, Holly, let's start with you here. When you hear these terms, high availability and redundancy, what do you think of? Do they mean the same thing to you?
I think I start with figuring out if they mean the same thing to the other person I'm speaking with. Because I think initially I kind of go down a road of probably redundancy. And I'm like, okay, high availability, redundancy, I definitely loop them together. But I think that high availability can mean a lot of different things depending on the context of your network, where redundancy is usually I'd say a little bit more specific. Like within high availability, you can use redundancy to make your network highly available.
I agree with that. Yeah. I look at redundancy as one of the tools in your toolbox to make a network highly available. And we're going to dive into this. It's funny. I started this question with Douglas and then started thinking, okay, we're going to talk about having redundant WAN links and, like router pairs or whatever. And then I started really thinking about it. It's like, this is a big topic. This is like really big. There's all kinds of things that fall under these headings. But thankfully, we're going to be able to nail this in, 15, 20 minutes, Holly, top max number of minutes for this conversation, as always, right? Because, that's how it works for us. Okay. Now you in your role you're at Juniper and you work with a lot of customers, helping them with their sales needs and so on. When you help customers with their network designs, do high availability, redundancy, do these terms come up in your conversations?
Every single conversation.
Oh, really? Okay.
If I think about it, I don't actually think I've had a conversation where it doesn't come up. I think it's a critical part of network design, especially specific types of customers. This is critical to them. So hospitals and financial firms, usually those are the two where you really can't have a conversation without redundancy or high availability. And even just some of the smaller customers, it's critical. Your business relies on the network, and if the network goes down, usually it's some sort of cost impact to your business. You're losing money. So there's always a conversation of how do we mitigate any risk?
Oh, okay. And then that was my follow-up question then. What are they asking you? Are they saying, hey, how do we design this so that it is highly available? Or do they express a specific concern and say, hey, help me solve this problem?
It could be both. Sometimes it's, this specific critical function relies on this switch, and we can't have a single switch with this critical function, obviously. So how do we create redundant links, or do we need redundant boxes, or what does that look like? Or it's just a general question of, we want to make sure that at any moment we have a highly available network. So maybe for upgrades, you making sure that you don't have to turn off an entire box to upgrade it, things like that. So there's lots of flavors of this conversation, and it just really depends on the use case and critical capabilities and things like that. What are you trying to do?
So it's not like you working on the sales side of things have to recommend this and then they push back and go, oh, you're just trying to sell me a bunch of stuff I don't need.
I think being a sales engineer, that's not. I come with a bit of trust with the customer. I think that
Hmm.
they kind of know that my objective, at least personally, like, yes, I have to hit quota, but personally, it's kind of like in the back of my mind, my goal is really to help you design a network that meets your needs. If that means selling you a smaller switcher router, I'm going to do that. I'm not going to give you something that's over spec'd. But it can be a challenging conversation when you're asking about redundancy and high availability, and often that comes with sometimes some sort of cost implications. If you want to buy two switches, two firewalls, two routers instead of one, even if it's just a backup, there's a cost to it. And sometimes there is pushback. Sometimes, you've got to look at different ways of getting to that same result that's maybe less cost effective, but the pushback is usually cost.
Okay, and that really is my final question on this to get your take. If you have an objection to this, it's usually budget related. It's cost.
Yeah. Or, I mean, in very rare cases, maybe space, like literally rack space. We have
Yeah.
space for one box in the rack. We can't have two, for example. But I'd say 90% of the time it's cost.
Space, that's a tough one because
Yeah.
I don't know how you
And
work
it
around
comes
that.
up,
Wow.
and I don't know what to do. I mean, that sometimes to get around that, you can sell some virtual equipment. So I don't know,
Yeah.
you've got one
Yeah.
firewall
Yeah.
on-prem,
Depending
you've
on
got
what
one in the
product is.
cloud,
Yeah.
depending.
Got it.
But that's a tough one.
Okay, so this is a big conversation. What we mean by high availability and redundancy. And again, Douglas's question: how do you approach designing a network for high availability and redundancy? So what I thought we'd do for the rest of this chat, Holly, is talk through a bunch of different tools and network design elements that you can use to deliver high availability. Some of those will be in the form of redundancy, but it seems that you and I agree here, Holly, that redundancy is one of several different things that you might use to bring high availability up. And redundancy is so common and has so many different forms and variations that I think it's easy to say redundancy equals high availability, but in my mind, they don't. Redundancy is just one of the things you would use to help you deliver that highly available network. So let's talk through. We got to, again, it's just a 20-minute conversation. I promise it's not going to be any more. Oh man, you should see my notes, people. I have lots of notes here, but let's.
Before we jump in, I'm going to pause you already.
Okay.
I think we should draw a line in the sand between redundancy and high availability. To me, at least, if I think of something being redundant, purely I think of a backup. If something that's the definition of the term of being redundant. Usually there's something that is a copy of something else.
Okay.
So you have some sort of a backup. But high availability doesn't necessarily, to me at least, mean that it is a backup per se. It's something that is there and can be active at the same time, not necessarily just if things go wrong.
Oh man, we're going to go down the rabbit hole of what words mean. So if we back up a second and just focus on the highly available portion, highly available network is one that is up a very high amount of time. And if we're talking about things like data center availability, you talk about it in the form of the number of nines of uptime. Like 5 nines would be 99.999% uptime, and 7 nines, 99.99999% of uptime, and so on. And there are requirements to have your data center be available for for that. And if the network is down or some portion of the network is down, that can chip into your however many nines of uptime that you've got. So when we're talking about a highly available network, we're talking about a network that is helping you meet that uptime goal for your infrastructure. Your IT delivery stack, all the technologies that you use to deliver your applications that your business requires to run, the way you make your money, or the supporting functions that help you function as a business, rely on all these different technologies. Networking is just one of them. Now, network is an interesting one in that if the network is down or is having significant problems, the blast radius can be huge, right? You can knock down not just one application, but potentially all the applications that are riding on top of that network infrastructure. And so I think network engineers are particularly sensitive to having the network be highly available because it can hurt so bad if things aren't going well on the network. Okay. I think I agree with you drawing that line in the sand between highly available and redundant. I don't know if I agree that redundancy could exclusively mean backup, because then we're going to get into what do words mean.
Or like duplication,
Exactly.
perhaps. Like if
Yeah, I
something's
like
redundant, you've
duplication
got
better.
two.
Yeah. I like duplication better. I like that. Okay, and I think I think
Okay.
that's probably the word. That's the word, because as we get into this and when you'll walk through a bunch of examples I came up with, and whatever else might pop to your mind that we add to this list, we'll see. I think I like that. I like
Yeah.
duplication. Okay, so let's talk through. We're going to focus on the redundancy portion of a highly available network and ways that you can help a network be highly available by introducing redundancy into your network. One way would be pairs of devices. So I've worked with lots of systems like this where there is a highly available or HA hardware pair of devices where typically one of those devices is active, the other is a hot standby, or a backup in this case, Holly, like what you were describing there.
Yeah.
That is ready to take over if the primary goes down. I've seen firewalls. That's really common. You'll have an active and a standby firewall. Load balancers is another one. You'll have an active and a standby load balancer. And when you see these highly available pairs, very often, I've never not seen this. There is a dedicated link so that state is mirrored from the active device to the standby device. You've got a dedicated network link just for that, so that everything that's flowing into that active box is mirrored to the standby box. It has a copy of all the state. I know that a connection from this IP address just came in and its flow is going out to this on the other side, and the point being that if the active device were to fail and the standby device were to need to take over, it can take over immediately. It knows all the state because it has had it mirrored to it in real time. That's a pretty common thing. Firewalls, load balancers. Another one that's kind of different, but I think fits into this category of pairs of devices are switch chassis that have supervisor engines or routing engines, depending on who the manufacturer is and how they define their words. But you'll have an active and a standby supervisor engine is something that I've seen. Is that you're nodding your head, Holly?
Yeah.
Do you run into any of these, either pairs
Yeah.
of firewalls, load balancers,
All
or
of the above.
supervisor engines? All
And
of
I
the
think
above.
this
Okay.
might be one of the most common and I don't know if easiest ways, but very common. You know, if you need redundancy, just get two.
Mm-hmm. Yeah. But it's
And configure
interesting
them correctly.
There's the gotcha here for me is if you buy a highly available hardware pair like this, where one is active and one is standby, you got a piece of hardware you spent money and it's not doing anything.
Yeah.
It's there just in case you need it, but it's kind of that nuisance of like, man, that's a lot of horsepower just sitting there waiting just in case I need it, and can't we actually use the thing? It's always been a bummer, and then there's licensing costs depending on the manufacturer. A lot of times you got to license that box, just that backup box, just the same. Sometimes not. I know some manufacturers give you a break on that. I don't know how Juniper does it, or if there's any one rule, but
It depends on what you're doing. But I think there's also the case where you've got it for redundancy, but you don't have to run it in an active standby pair. You can run them as active to avoid that case where you've got something sitting there doing nothing.
You can, yes. Which we're going to talk about fragility, but before the end of our conversation here. But okay, so the step one: pairs of devices. A bunch of different options there. Two, I would move from a pair of devices where active standby or maybe active, depending on the capabilities, to clusters. And I tend to think of a cluster as three or more devices that are carrying load. I mean, yeah, technically you can have a two-member cluster where they're both active. I've seen those, but typically it's you got three or more devices that are in that cluster, and there's some kind of clustering software that allows those three or more devices to act as one unified device. If one device fails, the remaining cluster members just take on the load that that device that failed was taking. And so you've built some availability and some capacity in there so that you can stand to lose a member of the cluster and have the remaining cluster members handle the load just fine. And again, there's different software for that. Clustering is a different beast than having just an active standby pair or even an active pair. I think clustering's a bit of a different animal. You
Yeah,
run into this one, Holly?
yeah, and I think one of the key factors with clustering more on a highly available side of things is kind of what I mentioned before about upgrades, where
Mm.
you've got a cluster, you've got, let's say, 3 routers, 3 switches, whatever in there, and you need to make an upgrade. And you don't have the option of bringing that entire cluster down. Some protocols or software allow you to upgrade them piece by piece and move the master of the cluster and things like that, which that's kind of one of those situations where that's highly available and not necessarily redundant.
And that is something you want to look for and don't assume that that's the way the cluster will work, because a lot of people will buy a cluster with exactly that in mind. Hey, I need to do an upgrade, and I can just upgrade one member of the cluster at a time, and the cluster can continue on processing traffic in production. I don't have to take the whole cluster down. I will tell you, back in the day, you might have had to take the whole cluster down. So
Yeah.
that's a thing that could happen, where and you get there to that moment as the engineer planning this maintenance window, going, I'm going to upgrade one at a time. It'll be great. We don't have to take the cluster down. And then you're like, you upgrade the one cluster member, and then it comes back up. Oh, I'm sorry, I can't rejoin the cluster because the other cluster members are a different version than I am. You sit there and just look at your face like, oh crap, what now? So this is one of those things you got to make sure. But I would hope in 2025 there's not too much of that kind of thing going on.
Yeah, one would hope, right?
One would
But
hope. One would hope.
things go wrong. Like, I think clusters, I mean, again, that could be a whole nother conversation on this, but upgrades of clusters and interlinked devices gets complicated, and I would always recommend testing this stuff before going and doing your maintenance window in a lab. Make sure you can do it. You don't want to deal with that in production.
I just had a thought of switch stacks, which isn't exactly a cluster, but kind of is. You could categorize a switch stack as a cluster, because usually you got a stack master of some kind, and everybody else is a member. And I've definitely run into that with switch stacks back in the day, where everybody's got to be the same version.
Mm-hmm.
And so if you bought this thing at the switch stack thinking I can upgrade one switch at a time and everything's going to be fine, I don't have to take an outage. You might, again, it's one of those things, you got to know what version you're on, what the software supports, and as you just said, test it in your lab first. You know exactly what's going to happen before you do it. All right, so we talked about pairs of devices. We've talked about clusters. Another way you can bake some redundancy in and add to the high availability of your network is protocols have different redundancy features baked into them, or ways that you can configure them to be redundant, even if redundancy isn't inherent in the protocol as such. So, for example, DHCP. I know we did a show on DHCP, Dynamic Host Configuration Protocol. Hey, I need an address, and the host puts that plea out on the wire saying it needs an address, and a DHCP server will respond to that DHCP client request. And we talked about DORA and so on. The DHCP, the discover, the offer, the request, and the acceptance. I forgot what DORA stands for, but there's that back and forth. That
sounded about right.
That sounds about right. Well, if you're looking for redundancy in your DHCP infrastructure, your DHCP servers, you can have 2 DHCP servers that are on the wire and make sure they're serving non-overlapping address pools. So server 1 serves addresses between 10 and 100, and server 2 serves addresses between 101 and 200, or something like that. The idea is just to not have overlapping pools, so that don't have two servers serving out addresses on the same range, because that could get ugly. You can get duplicate IPs in that scenario. But yeah, that's a pretty common
Yeah.
way to build some redundancy in with the DHCP protocol. DNS servers, you can have and typically would have more than one authoritative name server for a given domain name or zone. Very common. And in the DNS system, you list the public name servers that are quote unquote authoritative for a given domain. You don't just list one, you list 2 or 3 or 10, however many you need to handle load and have distribution and redundancy, so that your DNS server infrastructure is highly available. There's that running joke about it wasn't DNS. There's no way it could be DNS. It was DNS. So many problems in networking are tied to your network's inability to resolve a host name to an IP address because there's some kind of a problem with DNS. So having redundancy in your domain name server system is a very common thing. And then yet another thing would be there are routing protocols that support equal cost multipath, ECMP, equal cost multipath. That is, I got 4 ways that are of equal cost to get to the same destination. And so the protocol will share load across those, however many paths there are. OSPF supports this. You can do it with BGP. You can do it with a lot of routing protocols. That is a form of redundancy and load sharing. There. Are there more examples you could think of, Holly? Those are what came up at the top of my head.
It's funny because in the last 2 weeks, I've run into both DHCP and DNS, like not necessarily issues, but redundancy issues where DHCP, a customer, was worried because they were relying on a single server and we had to figure out how to get some redundancy there. And the DNS, well, it was DNS. Long story short, they had configured multiple DNS servers, as one usually does, but at a more specific level in the hierarchy, their redundant configuration got overwritten, and every single device was just relying on a single DNS server. It was like Google or something.
Oh, even though there were more than one DNS server available, no one was set up to actually use them.
And like things got a bit weird and couldn't figure out what was going on. Eventually, we realized that, oh, well, at this top level, you'd configured everything, but like at a lower level, it got overwritten and you were relying on a single DNS server. So, and I never thought of either of those as kind of redundancy. I'm just like, yeah, best practice. Why would you have one of them? But it's just funny that I've run into both of those within like the past 2 weeks.
But it's funny because it's redundancy, but kind of the subtext for this, even though we're categorizing these under redundancy, and that's accurate, but it can also be load sharing.
Yeah.
That is, you've set up a whole bunch of these because you need to distribute load across a bunch of different machines to handle this. So there's some more examples of this. Actually, our next topic here is a good one to get into that. That is the topic of load balancing, something we have not covered on NS for networking yet, right? We haven't talked through like a basic load balancing architecture and what that looks like.
I don't think so.
I don't think we have. So load balancing in a nutshell is a load balancer is a device that serves up a virtual IP and then distributes requests that come into that virtual IP across physical servers on the back end, multiple physical servers, typically called pool members. That's a pretty common terminology. So you got the virtual IP on the front that your clients are hitting. The load balancer receives those requests and distributes those requests to one of several different pool members that hide behind that virtual IP. And that's its job. And there's all kinds of craziness you can get into load balancers. Super fun. If you ever have a chance to get involved with load balancing as a network engineer, I mean, it was fun. I loved dealing with load balancers because you can get into some bonkers stuff on the front end of a load balancer. Like when things hit that virtual IP and you want to distribute load, what algorithm are you using to distribute that load? And you can get into things like actually code that is looking at the request that's coming in and making the decision on the code. There was one place I went where we distributed load based on source port, I think. If it was an even number, it went here. If it was an odd number, it went there. Things like that. You can dig into HTTP headers and make a decision based on something you see in the header, and write code making to make decisions based on that kind of stuff, and so on. Or you can keep it really simple. You can just say, hey, round robin. I want, go to pool member 1, and then pool member 2, then pool member 3, and then go back around to 1 and just distribute them evenly in that case. Or there's all kinds of ways you can make load balancing algorithmic decisions. Lots of fun. Oh, load balancers also have something called health checks, because the load balancer's got to know, can this pool member that's sitting back there actually handle a request? How do you know? Well, you keep checking its health. Hey, you okay? Hey, you okay? Hey, I just sent you a hey, are you okay? And you didn't give me anything back. You must not be healthy. I'm going to take you offline, and so on. And I'm sorry, load balancing's fun. I just, you're laughing at me.
I am. I love it. Like, I just love, like, the nerdy, like, when you talk about things, and I think every network engineer has their quirks where there's just something that the average person sitting there listening, be like, load balancing is fun, really? Like, and you sitting here, be like, oh, the cool things you can do with load balancing. It's just great.
Oh, it is fun. And especially, now this is going to sound really weird. When you get into load balancing and things are broken, something's not working right, then it's super fun, because it's like, okay, because now you get to consider traffic coming in on the front door, hitting that virtual IP looks one way. And when it goes out the back door to actually hit the physical server on the, to go to that pool member, it might look a different way. And so you're doing actually multiple packet captures. You're looking at it on the front, then you're looking at it as it leaves the load balancer headed towards the pool member to see, did something change in there? Is the load balancer messing something up, or is it okay or not? And I may have an issue, Holly.
I think we discovered this prior, but
Oh, this is not new information. Thanks a lot. Oh, anyway, load balancing is a way to introduce some redundancy to your network. Very common, but also, to go back to the earlier part of our conversation, is important for load sharing as well. That is a big part of the reason you can scale up an application to be huge if you want, by just scaling with more pool members on the back end, or buying a bigger load balancer. Load balancers come in many shapes and sizes. And so depending on the number of, you might judge how big of a load balancer you need based on its ability to support X number of connections per second. If you need 1,000 connections per second, that's a different box than one that needs 1,000,000 connections per second, let's say. And load balancing can do things like handle SSL encryption for you. So you can talk SSL to the front door, HTTPS, and then the back can just be plain text if you want. That's a thing you could do. You might not do it that way, but you could do it that way. And you end up sizing the load balancer appropriately. Okay, too much time on load balancing. On load balancers specifically. But here's a different type of load balancing that I think it's a load sharing function, but it's also a redundancy function, and that is Anycast. Do you know what Anycast is?
Funny that you ask, because if you had asked me this like a month ago, I would have said no. Yes, I do. I actually know what this is, because, as you know, I've been going through the book that you and Russ wrote, and Anycast popped up, and then I went down a rabbit hole of why haven't I run into Anycast before, and now I know what it is. So Anycast, let's see if I actually remember this, but it's where you use the same IP address or set of IP addresses for multiple different servers or hosts or something, so that packets are coming in and it's being distributed in some way across different devices, but actually the routing is technically the same because the end IP address is the same. Something like that.
Wow, that is not the clearest explanation of Anycast I've ever heard.
In my head, I had this really nice image in my head. It made sense, but what you said is correct. Yeah. But Anycast is, think about it from a global perspective. Using the global BGP Internet Routing Table, you're announcing the same IP address, or from a BGP perspective, it's going to be block of IP addresses, the same net block from multiple places around the world.
So here's an example. Google does this with their DNS servers.
Hmm.
So 8.8.8.8 and 8.8.4.4 have been Google DNS servers for forever. They announce the blocks that contain those IP addresses all over the place. So if I'm where you and I are in the northeast part of the United States, we're going to go to one set of Google servers where 8.8.8.8 is close, geographically close to us from a routing perspective. But someone who's in France, let's say, if they're trying to get to 8.8.8.8, well, Google has announced that same net block from somewhere in Europe, and that person in France is going to go to that same IP address, but hit a server that's geographically close to them. Times however many places around the world they are announcing that IP address from. Anycast allows you to connect to the version of that server that's geographically, or more like may or maybe not geographically, but from a routing perspective, it's closest to you. It's probably also closest to you geographically, but that isn't necessarily true because we know how fiber optic cabling works. Yeah. And Anycast is a great way to build not only redundancy, because if your announcement from where you and I are here in northern New England, in the United States, were to disappear because problems, network issues, or whatever, there would be all these other announcements that Google is making for that same net block in different parts of the world that would then pick up the slack. We'd be able to connect to one of those instead of the one that had been announced nearby us. So you get some redundancy from Anycast, but also it's a form of load balancing, right?
Yeah.
Because we're spreading the load around geographically, so that you're connecting to a server that's closest to you, and it's not literally one server or group of servers that's having to take in all of the requests globally to accomplish that. So, all right, yeah, go ahead.
I just think my explanation was clearer, but it's fine. We can continue.
It felt like I was following a pretzel. I was going around.
Yeah, exactly. And then at the end, you have the pretzel.
Beautiful. So another.
Yours was a breadstick. Yours was a breadstick. Mine was a pretzel. Everyone's got preferences.
Oh, okay. There's a meme there somewhere. DNS round robin is the next thing I wanted to bring up as a form of redundancy or load balancing. Now, DNS, when you get into the specifics of a given DNS server, I mean, its main function is to take a host name and turn it into an IP address, right?
Mm-hmm.
At its most basic, that is simply you as the person who is the DNS administrator going into your DNS zone file and saying this host name equals this IP address. And that's it. You have an A record that does that. If you put in multiple A records, because you've got several different servers that can successfully respond to that host name, in its very simplest form, DNS will just go round robin through that. Oh, okay. Yeah, the first time someone asks me that question, I'm going to give them this IP address. And the next time I'm going to give them this IP address and this IP address and this IP address until it's through the list, and then it'll start over again. Now, anyone who knows DNS knows that I just way oversimplified what's going on, because some DNS servers will say, here's all the A records that I have for this server. Pick one. And you on the client side are going to decide where you're going to go. Or there are DNS servers that will use carefully crafted algorithms to determine which IP address out of that list of IP addresses it's going to serve to you, because it's monitoring the performance of various servers around the world and going, for you, the best performing one's going to be this. I'm going to send you this IP address. Or this server seems to be responding very slowly. I don't think I want to send it any more traffic. And it makes decisions that way. DNS can get crazy what's going on under the hood, and the algorithms that might be underpinning that DNS server's responses can get quite complicated. And there are companies that have built entire businesses on their magic DNS server that accomplishes load balancing and redundancy and so on. So I cite DNS round robin as in 2025, almost as like a naive way to describe like load balancing and redundancy, but it's there. And if you look up DNS round robin, there's Wikipedia articles and other things that'll explain to you how it works. So I say there's more to the story to avoid some well actuallys here, because you can get crazy with what goes on with DNS.
Yeah, we're going to move on from DNS because I know that's another one of those topics that you get very excited about.
No,
Refer to our DNS episode.
I like DNS. It's another one that's fun. It is. It's another one that's a good time. I will stop now. Okay. Yeah, I have been scolded appropriately. Yes. All right. Okay. So we've talked about pairs of devices. We talked about clusters of devices. We've talked about the ways different protocols can be used in a redundant fashion. We've talked about load balancing and some different techniques and terms that come in under the category of load balancing, including load balancers themselves. Now let's talk about, let's zoom out a bit, Holly, and think about network architecture. Like if you're like at a whiteboard and you're drawing the interconnections between devices and network links and these kind of things, that sort of network architecture, what are we considering when we're talking about redundancy and helping us to create a highly available network? So I got a bunch of these, but are there things that you typically are faced with or are recommending for customers?
I think a couple on your list are really most of the things that I deal with. So, I mean, what's number on your list there is like redundant WAN links.
Big, huge one, yeah.
I was going to say, I'm trying to think if they've ever not had that, but most of the time, a network has at least 2 different WAN links.
I want to park on this topic for a second, because you get into some interesting details when you're specifying 2 or more WAN links. Do you end up having to spec those out, or is that just kind of like one of those elements of the design you're taking for granted?
I wouldn't say I necessarily spec it out, but it might be a conversation based on configuration of the edge router, perhaps, and what you're doing on that box. But usually, I'd say the customers spec their WAN links and made that decision before I come into that conversation.
So I've been in situations where I've had to help design, the wide area network connectivity. And so what we're talking about when we're talking about the WAN links, we're talking about, I've got a data center. I need to connect from that data center to the rest of the world. They could be internet links. They could be private WAN links, although I think that's less common than it was. There's some of that still going on for sure. And so you're considering multiple things. One is capacity. You need to have enough capacity so that if any one of those links goes down, you've got enough remaining capacity to carry all of your traffic. In other words, if you have 2 WAN links, I've got redundancy, but they're both at like 90% capacity, and then one of those links goes down, that other WAN link can't pick up all of the capacity that the other one was carrying, assuming that they were equal bandwidth. So you don't really want to be running any hotter than 50% capacity on any one line, just in case there's an outage, right? So you're thinking about capacity. Another thing you're thinking about is physically, where do the lines run? How do they connect to the rest of the world? One design that I did, we worked with the local carrier so that one of the lines was underground and the other was aerial. It was up on telephone poles. And the idea was, if a backhoe comes through and digs up the underground line, the line that's on poles should still be okay. And if someone hits a telephone pole and takes out the line that's on the pole, underground should still be okay, is the idea. You're trying to make sure that the physical path the line takes between your facility and wherever the next facility down the road is, are not sharing a common path as much as you can. Sometimes you don't have any control over it, but that's another one of those things you're thinking about. And then, of course, if you want to get away from physical media, you can look at wireless links now. There's a lot of capacity in wireless links that if you have line of sight between 2 facilities, you can add a high capacity wireless link that can help you with that physical redundancy that you might be looking for. So that's a thing. When you get into that, if you actually are someone who's listening to this and you can have that conversation, your telco, whoever your local rep is, they've got maps. And you can say, show me the maps. I want to see the map, because they can dig it up and tell you exactly physically where those lines are running from your facility to theirs. If you're going to one of their pops, something like that, that could be a thing that happens. Don't just say, don't take their word for it. They should, if you're like doing a request for proposal, they should submit in that response to your RFP exactly where the lines are going, so you know exactly what's up. Or they'll just, I mean,
I'd love to see that.
I don't want to impugn anybody, but some people, to get the business, will just say, yeah, it's redundant. Yeah, physically separate paths, 100%. No. Make them show it to you. They have those maps.
That's definitely on my to-do list. Find a map.
Again, the telcos have this stuff. Yeah, they have it. It can be a pain in the butt for them to get it, but they've got it. All right, here's another network architecture that's a lot of redundancy that I think you're familiar with, Holly. This is leaf spine data centers. You spend time in this world, right?
A little bit. I mean, there's all sorts of calculations here for redundancy and like oversubscription things about ports. You need redundant ports, never mind just having redundant like switches. It gets very interesting, actually, if you understand what you need and your level of redundancy that you require. You can calculate all of this, which I enjoy because I like maths.
You can, yeah, and it is, by and large, it's a math problem. So a typical design will have a server that's got two uplinks to two different top-of-rack switches. The two top-of-rack switches are multi-home to multiple spines. And so you could lose a top-of-rack switch. The server still got a link to the network. You can lose a spine switch, and you still got multiple connections from your top-of-rack switches into your spine. And the oversubscription thing you're talking about is related to the tiers in your leaf spine switch. So if you've got however many front-facing access ports, the ports that your servers plug into, how much capacity do you have from the leaf switch down into the spine? And can you carry all of the traffic? If every server was yelling as loud as it could, filling the line with traffic, times however many front panel ports you've got that are uplinked to servers, could you carry all that traffic from the leaf switch down into the spine? Or are you, quote unquote, oversubscribed? Because maybe you've got, 480 gigabit per second of front facing panel ports, but only 100 gig going from the leaf switch down into the spine. So you have a roughly 4 or 5 to 1 oversubscription ratio. What is an acceptable oversubscription ratio between your leafs and your spine? And as you say, it's a math problem.
Yeah, and then this kind of comes back to the question of also what we mentioned before, like when you have two pairs and you have a box that's sitting there doing nothing, kind of similar specifically with leaf spine data centers is the stuff's expensive. So ideally, you want it to be just redundant enough, but not so redundant that you've got ports doing nothing or switches doing nothing, because the cost associated with that is huge. So it's a bit of a balancing act there.
And also, a lot of what drives this will be the nature of your traffic. If you're running an AI compute data center with absolutely massive data sets where you really are filling pipes, substantial, large pipes for considerable amounts of time while you're moving all the data around, you're solving a different problem than someone who, say, has a bunch of virtual machines, sitting in a rack that are mostly used for web traffic that's very bursty, where it's not, you're not consuming huge amounts of bandwidth for extended amounts of time. You've got very small bursts of traffic as you do database calls or serve up web pages or whatever. Very different traffic patterns where you can tolerate a much bigger oversubscription ratio than you maybe otherwise could. Yeah, if someone says that they want you to build a non-blocking data center, where that is, literally you've got enough capacity between leaf and spine that you can carry all the traffic for all your servers at 100% of line capacity. presume that they've got very deep pockets and have very specific data needs for them to ask you to build that. And I'd be going, I can build it. You've got the funding for this. And what's the traffic? What are we doing here? Because that hopefully they know what they're asking for when they ask for that. Some other quick examples, Holly, moving beyond two or more WAN links and then leaf-spine data centers. Ether channel or port channels, very straightforward. Is that what they call them in Juniper World? I forget.
I've heard that terminology.
I know that's Cisco terminology, and I tend to think a lot in Cisco terms. But you're taking a bunch of lines between switches and making them act as one virtual interface.
Yeah, I don't want to conflate things, but I think we often refer to them as just lags, which is link aggregation links.
Okay, link aggregation.
Yeah.
Okay, yeah.
We don't, it depends who you speak to, words.
Yeah. But what do words mean? But that's another very common way to introduce redundancy in your network architecture. And it's usually free, quote unquote, because if you got switches that can do it, it doesn't cost you anything other than you're tying up the ports themselves. So you take a bunch of 10 gig ports and make a 40 gig port, quote unquote, out of that. Using that technology, link aggregation in some form or another. SD-WAN tunnel meshes would be another one where all of the SD-WAN routers that sit at the edge of all your different remote offices form meshes to one another. That's a form of redundancy because that all happens dynamically. They know about each other and they can stand up tunnels where they need. And if someone goes offline, you still got connectivity elsewhere. And there may be some backdoor ways you can get some redundancy in there. SD-WAN tunnel meshes can get pretty fancy and clever with how they do what they do. Another example would be maybe you're spending the big bucks for a DX connect, direct connect to the AWS cloud, and but you've got a VPN tunnel as a backup. You've architected something like that. That's pretty common. Or you've got some kind of a direct connection to someone using an internet exchange point. And, but that goes down. So you've got a VPN tunnel as a backup, so you've got some redundancy. You've built in network architecture there. And there's a bunch of other ones. Was there anything that popped to your head you wanted to mention, Holly?
I mean, I think with regards to meshes, there are other places that you see meshes. I just was discussing kind of a wireless mesh system based on some cabling issues, things like that.
Sure.
But there's 101 different ways that you can change your architecture to create some sort of redundancy and high availability, and some of them are non-standard and interesting. Yeah.
Wireless mesh is a good example. If the link from the AP goes down, it could use one of its radios to join the mesh that way and backhaul traffic over that other radio. Yeah, for sure. You can have redundancy. We got to move this conversation along. How did we go over 20 minutes? We're at 47 minutes right now. What happened? I don't know what. I did not expect this to happen. I am shocked.
Should start betting on this. I'd be rich.
So yet another form of redundancy you might find that can lead to high availability is redundant data centers, actually. So if we're zooming way out, you can literally have multiple data centers that will have a common network that connect them. And those data centers can very often would be active, where they're both processing production data, but either data center could take over for the other one if necessary. You've got a data center based in North America that happens to be in Hurricane Alley, and the hurricane's coming, and it takes out. You have, due to this natural disaster, you've got flooding in the data center because of the hurricane. That's a thing that could happen. It'd be horrible. It'd be a bad day for everybody. But that's a thing that could happen. This is why we don't have data centers in the hurricane zones typically. But anyway, you could. So you do. The other data center would be able to pick up all of that traffic. And the implication there is neither data center should be at over 50% capacity. Again, you always got to be thinking about the capacity planning when you're running active anything, and you're expecting one member to take over for the other if it were to go down. But I will tell you from experience, there's work you got to do to support this kind of infrastructure. There is DNS work, there may be routing work, there may be BGP work. IP addressing work, network address translation can come into play. It can get hairy running active data centers and needing to have backups for either side to support the other one and have it all work seamlessly. It depends so much on how your applications were designed and what dependencies the applications have on specific IP address blocks. As soon as you have applications that are married to specific IP addresses or IP address ranges, it's just so much harder than it needs to be. And very often the application folks will be, nothing I can do about it. It's the way it is. Can you do magic, network guy, and make it better? And then you, the network person, have to somehow make it better. Holly, you're nodding your head.
Yeah, it's interesting. I feel like I run into a lot of these stuff recently for some reason. I don't know. Maybe I'm just happening to run into those kinds of customers, but I never thought about like full data center redundancy because that's crazy to have an entire other data center, but it's necessary.
Yeah. And to be fair, in 2025, what are you more likely to do? Probably it's some kind of a hybrid arrangement. It's not your own data center. It's probably a lot of stuff that's in the cloud. I mean, it depends. Every shop does its own thing for different reasons and what their data requirements are and cost to operate and so on. But yeah, it's a lot of the same principles can apply if you're operating in the cloud too. Although if your app successfully runs in the cloud, I think you're less likely to run into the my application's married to these specific IP addresses problem, because cloud operators like AWS and Azure and so on don't allow you to fit in. You can't do that. You can't play that game with them because they're like, no. If you're going to put workloads and deploy them on our cloud, you need to have them be appropriately designed so that they can run in our cloud. And we're not going to bend to your needs for specific IP addresses necessarily. There's a lot of it depends here. There's a lot of well actuallys here. I understand that, but just saying. Now, disaster recovery data centers is another thing where you've got another data center that's basically offline and not doing much. And you, in the case of an absolute catastrophic failure in your primary data processing facility, you bring the other data center up. I don't know how many people do that these days. I mean, I haven't heard about that in a while. Have you run into that one, Holly?
I think it's maybe been discussed like in passing, but I haven't actually seen one or had a customer that specifically has one.
Well, it's such a waste of resources just to have stuff sitting there. Plus the joke about a quote unquote disaster recovery data center that you're only going to spin up because something horrible has happened elsewhere is that data center is going to have a bunch of older gear that hasn't been running for a while. It's where your leftover stuff you cycled out of your primary data center goes up. That old switch, that old server, that old whatever, send it to the backup data center. And, we can use it over there just in case. Meaning you got a bunch of stuff that you're sitting in that old data center that you're not, isn't production quality anymore. Yeah. It's your cast offs and your leftovers. So how good's that data center going to be if you actually need it? I don't know. So I don't know how many people do this other than just saying, I know it's an architecture that some companies may have. It may exist. You might run into it. But I wouldn't think that's very common these days.
Yeah, I mean, that kind of what you mentioned there, cloud specifically, is definitely another topic that I see often.
For sure, yeah.
A lot of use of cloud in all different ways to create redundancy, high availability, all of that.
Very much so. And I think that's far more likely to be what you're going to run into these days. And just quickly, because, okay, I'm joking about 20 minutes. Now we're coming up on an hour, and I have... Okay, there's way too many words left in this script. We might have to punt this to another show.
Yeah.
Okay. But yeah, I mean, redundancy in your compute and cloud architecture, things like Kubernetes clusters. Okay, we're not going to talk about Kubernetes clusters. That's not a network thing. But I wanted to point out that the whole idea behind Kubernetes is redundancy. That's a huge part of what it's delivering for you. Okay, so as a network engineer who's supporting Kubernetes clusters, you should be aware of where all the worker nodes are and make sure that the network underpinning that Kubernetes cluster architecture is itself redundant, and that you're not if the network goes down, you didn't just take out the whole cluster, would be the way to think about it. Make sure that the Kubernetes cluster can deliver the redundancy it's designed to deliver, because the network it's riding on isn't itself redundant. Cloud bursting's a thing. I don't know that many companies are doing that specifically in 2025. Maybe you got some insight there, Holly, but that's the idea of,
No.
I'm running workloads in my own shop and I'm going to send the extras because it's very busy all of a sudden up to the cloud to process. That was really trendy. I don't know, 8-10 years ago. People were talking about that a lot, but I don't think it ever took off.
I haven't actually run into that at all. So I would assume not.
No, and that makes sense to me, because it was one of those, like, it's actually really hard to just throw workloads up into the cloud and spin them up and have them start doing things. Kind of like the disaster recovery
getting data in and out of the cloud is expensive. So I don't think it's as easy as it sounds to just send it up and send it back down. Like there's a high cost to that as well.
Now, something you should be aware of as a network engineer working with cloud networking or availability zones, cloud architects are expected to understand and implement availability zones, which are, you're spreading your workloads across multiple availability zones, which is a specific term in cloud architecture that implies redundancy. You have workloads in multiple availability zones. One availability zone goes down, the other availability zone should be up. That is part of what the cloud is providing for you, whichever cloud you're in. So that's one of those things to dig into and research if you had not heard of AZs before. And again, the big point is you got to understand the workload, the compute that you're supporting as a network engineer, and make sure that the redundancy that the compute architecture is delivering is supported by the redundancy you're delivering in the network. So, oh man, there's way too many other things to talk about. There's a whole other show here, isn't there? But
I think so, based on the page and a half left.
Yeah. Okay. Well, so we'll give you a teaser then. I think Holly and I will record another show about delivering high availability that are things beyond just redundancy. We spend most of our time talking about redundancy. And Douglas, hopefully that more than answered your question, at least got you going in the right direction on things to be thinking about, even though we didn't get into detailed stuff. But other things to deliver high availability, we could talk about rapid failure detection, dealing with active instead of active standby, the concept of graceful degradation, proactive failure detection, and then how to actually implement this stuff, some of the concerns about money. And then a big concept I'd like to spend time talking about, not today, but that is fragility. That is the notion that when you add redundancy to a network, you've made it more fragile because you've made it more complex, and the irony that you find with that. It's sort of irritating. I put this in to make it more robust, and somehow it's now weaker because of the thing I added to make it more robust. That's a thing. We can talk about that more, and I think we have another show to do, Holly, where we talk about this stuff.
Yes, definitely.
Yes. Okay, parting thoughts?
It's funny because you start off asking me if I've come into this stuff, and I'm like, who hasn't? And I'm curious if there's anyone out there who doesn't think about redundancy and high availability. And maybe we should chat, because that would confuse me. But I just think it's like such a crucial part of networking.
I'll put it to you this way. One of my jobs over the decades of supporting networks is to kind of be put on my fireman suit and jump in and like, okay, things are on fire. Let's put the fires out. And the reason things are on fire very often is because a lack of redundancy was there, even when there are things that could have been done for free that would have cost the business nothing, that could have been leveraged. And so it comes down very often to the knowledge of the network engineer and their willingness to confidently put these systems in place, because there is some design and architecture work that goes into it. Is it a concern for everybody? Yeah. Does everybody do it? No. I'm afraid
Fair
not.
enough. Yeah.
So, well, all right. So Okay, let's wrap this one up, and we're almost going to be under an hour. So thank you for listening to N is for Networking today. We appreciate your comments, your requests for topics, your actually input, and you can send us all those things via packetpushers.net/follow-up, or send us an email, N4N voicemail at packetpushers.net, N the number 4, N voicemail at packetpushers.net. And if you were watching this on video, you wouldn't be able to tell. But Holly just reminded me to tell you about the N4N voicemail at packetpushers.net. We want your voice memos so that we can include them in the podcast. We think that'd be super cool. When you hit packetpushers.net/follow-up, automation magic happens, and your follow-up appears in a private Slack channel Holly and I use to plan these shows. And it's not that magical. It's just Zapier. But hey, it works, and we really appreciate it when you use that form, because we don't lose track of them that way. If you would like, share, and subscribe. If you're watching on YouTube, hit that like button, for example. If you're listening on Spotify, leave a comment. We're starting to see comments come through on Spotify. We appreciate that stuff. You get the idea. And again, kind of a big deal for us as we help grow this show. And then last but not least, just remember, networking isn't hard. Other people figured it out, so you can too.